Okay, yeah, Sarah, have you got your run sheet to hand?
Yes, and you know what? This is the first time I've looked at it, and it's
That's
funny that it's taking this angle because my own children were asking me about this certain person
nice.
today.
It's corny. You're gonna have to bear with us for this section, Zoe.
Yeah.
This is the corniest bit. I even cringed when I reread what I'd written, but we'll go with it.
Yeah.
Okay, you ready?
Yeah, let's do it.
Hey, Sarah, have you been good this year?
I've been reasonably well behaved. Why?
Because we're making a list and checking it twice
And we're heading to the North Pole.
to check the extent of the Arctic sea ice. No ChatGPT involved in that intro. That's all pure me.
Pure corny.
Pure goofiness. In a previous version, I'd written to save the remaining sea ice, and I was like, oh, that's awful.
Yeah.
I'm not writing that.
My name's Sarah Perkins Kirkpatrick, and I'm a professor of climate science at the Australian National University in Canberra.
I'm Ian Strachan, a former journalist turned science communicator. We're members of the Australian Research Council Centre of Excellence for the Weather of the 21st Century.
And this is Totally Cooked, the Climate and Weather podcast. We're excited and grateful to be joined by Dr Zoé Koenig of the University of Tromsø, the Arctic University of Norway. A lot of big words. It's past 8 p.m. here.
I wrote it, which is most unfair.
Zoe is an oceanographer who studies the ocean dynamics of the Arctic Ocean, particularly the relationship between ice and ocean.
Zoe, we get a lot of really good out-of-office messages and explanations for delayed responses in this job, but I particularly liked your reply to my inquiry, which said, sorry for my late reply, I was at sea last week. I really like that, and I want to know where you were at sea and why you were at sea, please.
So, yeah, I spend a lot of time at sea, but this one was actually not for my research. I was with my students because I'm teaching here, and that's something very great they have as an opportunity here in Tromsø. So I'm teaching ocean climate. That fits nicely. And I bring the students for 6 days in the fjords around Tromsø. And they actually have to design kind of a research question. So they read papers about the region, come up with a question, and we go on the field to try to validate or look at their hypothesis.
Are those undergraduate students, or what level are they doing?
Yes, it's their third year of bachelor. So we have a lot of student cruises. So I had mine for 6 days now, and I have colleagues going for marine biodiversity, where they're gonna go look at take nets and trawl and get to see the birds. So yeah. So that's the one I was at when I answered. But I'm also going quite often for work, for my research. And you would have asked a bit later in the months, that would not have worked too, because I'm gone July, August, for example.
So how many cruises would you do a year to do your research?
One to twice a year, but there are long cruises when we go to the Arctic because it's expensive to get there and it's far. I guess it's a bit the same as Antarctica for that. Yeah. And so they are usually 4 to 5 weeks. At least the Norwegian cruises are usually 4 to 5 weeks. Now I'm going with the Polarstern, so the German icebreaker. And this one, I'm leaving on the 2nd of July, coming back on the 1st of September. So 2 full months.
Yeah.
Where do you sail from when you go on an icebreaker?
Depends where we go in the Arctic. During my PhD, my PhD was about deploying instruments a bit everywhere in the Arctic to understand the ocean dynamics. So I had once I left from Nome in Alaska and then came back in Barrow in Alaska also. So that's more to look at the Canadian side, American side of the Arctic. But now I'm more working on the Eurasian side of the Arctic. So Europe, mainly between Greenland and Russia, let's say. And there we usually start either from Tromsø, which is very convenient to start from home. I just take a little taxi to get to the boat. Or we start from Longyearbyen, Svalbard.
I was about to ask, that's my next question. Have you been to Svalbard? It's on my list. I'm really curious about it.
Yes, I've been to Svalbard several times, mainly for fieldwork. associated with the fieldwork. Sometimes for research also, we have some, there is a university in Svalbard, UNIS. So they have researchers there. So I've been on research stays there for 1 to 2 weeks in a row.
I was going to say, for anyone listening at home, Svalbard is, I think it's an archipelago, a group of islands off the coast of, well, in the Arctic Sea, off the coast of Norway and Finland and Russia.
Yes, it's an archipelago. Basically, it's one of the shortest place you can go, like the closest place you can go to from Tromsø. Oslo is further away by plane than Longyearbyen. Longyearbyen is 1.5 hour plane. Oslo is 2 hours. So we are closer to Longyearbyen. It's an archipelago, and it's not a common status because it's not Norway. It's an international territory under the governance of Norway or something like that.
Yeah, Norway's sort of like a caretaker, right?
Right.
Yes.
Okay.
So but for example, the taxes that are paid in Svalbard are only used in Svalbard. They're not being used in mainland Norway.
Okay.
So
and this is somewhere I've read that if you want to do field work or research outside of the main settlements in Svalbard, you have to be pretty prepared, including being trained to use a rifle in case polar bears take an interest in you as a snack.
Exactly. There is Svalbard hosts a pretty big community of polar bear. I wouldn't say the number, but a big one. And what is considered safe is basically the town, and I think the road from the airport to the town, and that's it. As soon as you get out of that, you need a rifle. So even for hiking, it doesn't only involve research. But also when I do research from the ships, the icebreakers, it's the same. We need rifle when we go on the ice because we are in polar bear territory.
What's the likelihood that you might see a polar bear? Like, obviously you need to be prepared, but is it likely that you would see one every time you went out, or is it like just a low risk? Something that's low frequency but high risk situation?
So in Svalbard, I don't know. I won't say because I've never done fieldwork in Svalbard.
Yeah.
So I can't say in Svalbard, but from ships when we're on the ocean, we've seen polar bears during every cruise.
Yeah, okay, wow.
But you have also the close encounter and the far encounter. So there is a full system of watch that is being put in place. So shooting the bear is really the last resort. We are not shooting the bear.
Yeah.
So it's more we watch, and if we see a bear that is coming close by, we all go back to the ship on safe terrain, and then we don't have to shoot the bear because it's not life-threatening situation.
Of course, yeah. Still fascinating to see one in the wild. That's amazing.
And Zoe said that you're safe in the town and you're safe on the road from the airport to the town. But if you've arrived at the airport, don't get in an Uber or a taxi driven by a polar bear.
That would make a lot of sense.
Yeah. Only use properly licensed human-driven vehicles. That's how they get you.
Yes. You're straight to the barbecue from the Uber.
Sarah, can I steer you towards the first real question we actually have? This has all been wonderful nonsense about not shooting bears. I think that maybe, what Zoe said is that it's absolute last resort. If you've done it wrong, then you might have to shoot the bear. I feel like that could be an expression for, do your planning right. We don't want to shoot the bear here, people. Like, let's not let it get to that.
Maybe we need to, make that, coin that term in 21st century weather.
I'm going to start dropping it into CI meetings and see if people question it. And if you just agree with me and nod sagely, then people will think that they should know what we mean and that it's obviously a common expression.
This is a really good experiment. I like it.
Okay.
Cool. Let's do it. Okay. So the first real question, can we talk about the seasonal cycles of Arctic sea ice?
No, that's not the first question.
Oh, that's where I am.
What?
Very common. I have no idea.
Profesh. It's under the heading, what and where is the Arctic?
Oh, wow. I've skipped ahead.
You assume that everyone knows, don't they?
I do. Well, I don't. This is why I've been listening to Zoe, because this is just a brave new world for me. Okay. All right. So hopefully this question is more straightforward than what I launched into. What is the Arctic?
The Arctic, it depends on the definitions you take. There are several definitions. But for me, an oceanographer, the Arctic is mainly the Arctic Ocean. So it's an ocean centered at the North Pole that extends basically all the way to the north of Canada, the north of the Alaska, Siberia, and then Greenland and Svalbard, more or less. That's what I would consider the Arctic. That's the Arctic Ocean. It's an ocean surrounded by land with just very few openings towards the rest of the ocean.
Okay.
Perfect.
Like there was a couple of follow-up questions, but
the follow-up questions have been addressed. I said that we have written here, it says follow-up questions, if not already covered. Where is it? How do we define it? How far does it extend? No, done.
Tick. German efficiency right there.
So I get the next question.
I do have a question, though. I do have a follow-up question. So, Zoe, you've just talked about like ocean, so the ocean aspect of the Arctic. What about the ice? For being an Australian, I often associate the Arctic with having at least some ice at some point. How does that kind of come into, defining the Arctic? Is that part of the definition, or, as you say, does it depend on what you're looking at?
There's two types of ice. So we have the ice that sits on land, that's the one from the glaciers, and we find it mainly in Greenland, that's the ice caps. And we find them a bit in Svalbard, but less and less. In terms of Arctic, of course, Antarctica is full of ice.
Yeah.
But this ice, for me as an oceanographer looking more at large-scale ocean dynamics, the main thing they bring is fresh water into the ocean.
Right. Okay.
Then we have this... Sorry?
Go on, Zoe. I'm going to make my helpful remark in a minute. It's directed at Sarah.
Go.
And then we have the sea ice. And that's what covers most of the Arctic. The sea ice, that's very oceanographer-centered. For me, is frozen ocean.
Yeah.
Because it's a resultant from basically the ocean freezing and forms ice on top. Okay. And this one is the one that we talk is shrinking, is extending, as this seasonality. So when we talk about sea ice extent in the Arctic, we're never talking about what's happening on land. We're talking about the sea ice, which is from 1 to 10 meters thick on the Arctic Ocean.
Okay. Cool. Thank you.
So my question was going to be spotlight on Arctic sea ice. And this is what I've written here. It's redundant now. The Arctic Circle is very different from Antarctica. It's not a landmass covered in frozen ice, but rather it's open ocean covered in sea ice, which advances and retreats with the seasons. Zoe, can you tell us more, please, about the important differences between sea ice and land ice? Nah.
So, sorry.
Whatever.
I haven't catch this. I know what happens when I read ahead.
And the next question says, Sarah brackets, if not already covered. I'm taking this back. So, Zoe, thank you for...
No, I was going to sit back. You take the episode over, Ian.
No, it's fine. I mean, it just shows you've got strong instincts as a journalist that, you've been asking the question that I spent time thinking about writing it. You just thought of it on the spot. So
just waltz on in, sit
just
down.
A natural.
8:30 p.m.
So, Zoe, to follow up on your answer to Sarah's stolen question, can we talk about those seasonal cycles of Arctic sea ice? When is it at its maximum and minimum extents, and why, please?
Yeah. So the Arctic sea ice has a very strong seasonality. It's minimum in September, sometimes around the 15th, 20th of September. It's maximum end of March, beginning of April. The reason is pretty simple. You need to freeze the ocean. So that's happening during the winter when it's cold atmosphere. That's when you get your ocean freezing. And basically before it starts to get warm again, that's when you have the maximal extent. That's why the maximal extent is not in December, but it's at the end of the winter. And then same for the minimal. The minimal extent is in September at the full end of the summer.
I have a question. May I ask a question, Sarah?
Oh, yes, you can. Thank you.
So how do we measure that extent, Zoe? How do we record how much sea ice there is, and how has the way we record that changed over the years?
So now we have a very great tool to measure the sea ice extent, and that works pretty well. It's the satellite observations. So via satellite, we get images, and I mean, we have different of colors, and basically by image processing, we can know the extent of the sea ice on a daily basis, basically. And you can find very nice websites. I think NOAA has a very nice one where you have maps of sea ice being updated every single day.
That's incredible.
This is very good, but it gives you the extent of the sea ice. What we are very interested in as researcher now is the volume of sea ice.
Okay.
Because the extent just gives you how much there is around. The volume gives you actually the quantity of sea ice.
Can I propose that website should be called Ice Ice Maybe?
We should do episodes at this time of night all the time, Ian. You're on fire.
I'm sober, honestly. All I had was some dal.
I did have, what did I have? I had pasta bake. I now I want to fall asleep because it was too heavy. Anyway, I did have a question about the volume. So we've talked about sea ice extent a little bit, but how do we measure the volume, and how does that change with the season as well?
Yeah, the volume is much harder to document. The volume also is what indicates also the change with the climate change. Because you can see that if you get ice that can survive from one winter to the next winter, so can survive the summer, of course you will start growing it when it's already maybe 50 centimeters thick. So you will reach thickness of sea ice that are much bigger. On the other hand, now we have a lot less sea ice in summer. We have a strong sea ice retreat in summer. That means we always have to start from scratch to grow sea ice. And we don't reach at all the same thickness that we used to reach if the sea ice can survive the summers. So the sea ice extent that is retreating in summer, but is not so much retreating in winter. A little bit, but the trend is way less. It is being reflected a lot in the sea ice volume decreasing. And basically the thickness of the sea ice is decreasing, and we are losing one type of sea ice, which is a multi-year sea ice. And that has huge implications in terms of ecosystems and life, because this thick ice is the one disappearing more and more. And to measure the volume, it's quite hard. That is not easy. We have some satellite. We have a new satellite, Cryosat, that is made to measure basically the thickness of the sea ice. But it's quite hard because the way to measure the thickness of the sea ice, we use the isostasy principle. Basically, if we have an idea of the density, it's like icebergs. You know how much is floating, and then you can measure how much is below, right? But this works if you have a very good idea of the density of the ice. But if you have snow on top, how do you know? The snow has a different density, and that might play like the cap system and pushing the ice a bit further down or further up, depending on how much snow you have. So it's harder. There's studies and it's being used, but it's much harder than the sea ice extent to define.
What was that metric called? Sorry, Zoe. Was it iso density or?
So it's the density of the sea ice and the density of the snow, but the principle is the isostasy. It's the same that why you have mountains that are this height into the earth. It's the same
okay.
idea.
Isostasy. Well, that's a segue actually, because that's a term I've learned, but I also read a new term that I haven't heard before when I was researching this episode. I'm not even sure I'm going to pronounce it correctly. It's the either albedo or albedo effect. Is that
Albedo.
something? Albedo. Can you explain that to our listeners and to me, please?
Yeah, the albedo is basically the capacity of any surface to reflect the sun. So the main source of heat for our planet is the sun. The sun, of course, it emits radiations, or like forcing the sun is hitting land. A lot has already been diffused in the atmosphere, but whatever, what's end up reaching land, part of it is being reflected straight, part of it is being stored as heat. The albedo gives us an idea of how much can be actually sent into the atmosphere versus what is being stored by Earth. You see it pretty easily when it's summer. Oh, sorry, someone is knocking at my door. I'm just going to check.
Bring them in, get them on the show.
Like, genuinely, have you not heard of albedo before, Ian? Like,
what are you trying to say?
Because I was like, if you haven't, I failed you. I should have introduced you to this term.
Too late. I've passed my probation. Zach and I both in for the duration of the centre now. So sorry.
No, I know, but this is like a very, for want of a better word, basic term. But I feel I'm genuinely surprised that you haven't yet come across it.
Basic term for a basic bitch. What can I tell you?
Yeah. So no, albedo, I was going back, like it's the same as in summer. You wear white clothes, you're less warm than if you wear dark clothes, because the dark absorbs the heat, the white reflects it more. So the sea ice reflects more the sun and keep the Arctic kind of cool. Now you have the sea ice retreat, so you have more and more open ocean, it's dark. So that absorbs the heat. So that makes the system heating even more. And that's what we call the positive feedback. Like, you have less sea ice, will generate less sea ice because your ocean is getting warmer, will melt more of the sea ice, and the white is disappearing and the black of the ocean is appearing more and more. So of course there are some other feedbacks that can play and inverse the trend, but the albedo trend will only make the sea ice disappear. It will not make it reappear.
Just to reassure you, Sarah, I think that actually I have heard you talk a lot about the need for light-coloured roofs rather than dark-coloured roofs. And it's actually a triumph of your science communication skills that you haven't used the fancy term. You've just described the process and given a clear example of why a dummy like me would know. So it's all good.
I was like, how have I not told you about my white-coloured roof before? Basically about me.
I could have taken the example of the house in Greece. That's also the other example. Houses in Greece are white. But
anyway, so a bit of a digression, but I just wanted to kind of, like, for the audience, mention what a positive feedback is. Like, it's not, so a positive feedback is not necessarily something that's a good thing or positive. It's when a process is amplified by its own process. So Zoe's just talked about, if you have less sea ice, it absorbs more heat, which means that there's less sea ice. So that's the positive feedback in there. It's amplifying the original process. Ian, you're smiling, and I don't know why.
The only positive feedback we want is your comments and reviews of the podcast, please. Zach and I have been hanging on to say that. Going like, wait till the serious answer is over. We can make the joke.
But yeah, like I remember learning about positive feedbacks in my undergrad. I don't know, however long ago now, and it takes a little bit to get your mind around. It's not necessarily a good thing. It just continues to amplify itself.
Be about 20 years, wouldn't it?
Yeah, I didn't want to say that out loud. It was a bit of a reach.
Just after The Day After Tomorrow came out.
Yeah, pretty much. Yeah, around that time. Where are we?
In the course of this most recent kind of discussion, have we touched on the concept of Arctic amplification at all in this discussion of feedbacks and processes, or is that something separate, Zoe? And if it's something separate, can you tell us about it, please?
Yes, it takes part of the Arctic amplification. The idea is that when we talk about global warming of 1.5, 2 degrees, depends which scenario you're looking at and which regions, but it's always global warming we talk. In the Arctic, we expect 7 to 8 degrees. So we expect much more warming in the Arctic than we see in the rest of the world. The albedo being one of the reasons. There are also others, atmospheric circulation and everything, but the albedo for sure plays a role. And that's also why now in the media, or in general, it's quite easy to use the Arctic as being the sentinel of the global warming, because it's actually the region where we already reached 3 degrees or even maybe 3, 4 now. I can't remember exactly the number, but we're already at this amount of degrees above the average, the normal. So that's why the Arctic is also being used so much, because it's actually a place where we see the effect, because we have this Arctic amplification.
But is it something to do as well with the fact that there's a lot of land in the Northern Hemisphere and in that part of the Northern Hemisphere, which warms faster than the ocean?
Yes, for sure. The fact that it's surrounding with, Arctic amplification is stronger than Antarctic one, but there's still polar amplification anyway, and that's mainly albedo and loss of albedo. But yeah, the fact that we have the lands around makes the Arctic a very constrained system also. And that means that the land heating around also impact quite a bit the system.
Zoe, can you tell us when the lowest sea ice minimums were recorded? How recently has that happened?
All the minimums have been in the last 10 years, so it's pretty easy. We always talk about 2007 and 2012, those were very, very low, but we reached similar levels or even lower in the last 5 years. So it's not recovering, basically. It's staying quite low. That's the summer extent. The winter extent is also getting low, and we reach a very low this year. I don't know if it was the lowest one, but it was not far from the lowest one that we reached in 25. The summer one is, of course, a good indication, but the winter one too, because that's where you restock your volume of ice that is available for melting. So that's basically what will impact the sea ice volume in the end, quite a lot.
Do we expect to see an ice-free Arctic in the near future?
So, yes, that's been quite in the discussion recently. The studies are showing that we get a summer ice-free Arctic by 2050. We're never talking about a winter ice-free Arctic. So that's the first thing. When we talk about an Arctic ice-free, it's summer ice-free. The temperature now of the atmosphere in winters are around minus 30 in the Arctic. We're still gonna get some frozen ocean in the winter. The difference is that this sea ice will not be thick enough, and the summer will get warmer, so everything will melt during the summer.
And that was 2050-ish?
2050-ish, maybe a bit earlier. Depends a bit on the scenarios, and how we emit, how we keep going with the global warming. And also it depends on the models you're looking at.
Yeah.
Because there is some uncertainty there.
So we're talking about like sea ice extent or lack thereof in the future. What did it look like in the past? So what was the extent of it? What was the thickness of it prior to the Industrial Revolution? Do we have a way of knowing that?
Yeah, there is. Before the industrial era, we kind of have a way, because we can reconstruct the climate, right? So by using paleoclimate estimation, we can have an idea of how much sea ice there was, or at least where the extent was. That's we can know. I don't know exactly how far it was, but I can say, for example, in Norway, between Svalbard and Tromsø, we have an island halfway that is called Bjørnøya. Bjørnøya is Bear Island, translation. The reason is that there were polar bears coming there. They haven't seen any polar bears in years, and the sea ice does not reach anymore really this island on a very, very few occasions, but it does not reach it anymore. So the extent has been changing quite a lot over the last. But we're talking, recently. Of course, if you look at paleo studies like 1,000 years, 100,000 years ago, then actually the sea ice was going all the way to southern Norway and Europe. So it's a different story.
Yeah. Okay. Wow. It's changed so much.
Can you take or drill ice cores in the Arctic?
So yes, we take ice cores, but we don't take the ice cores that are used for paleoclimate. Those we take from land glacial ice. and they go down to 50, 200 meters, depending on where you are. In the Arctic, we do drill ice, but we take cores of 1 to 2 meters usually. If you drill a ridge, so a region where the ice kind of compress and create a little mountain, you reach maybe to 10, 15 meters. If you drill north of Greenland, that's where you have the oldest ice, so the thickest one, you reach maybe 6, 8 meter. It used to be more 10, 15, but now it's 6, 8 meters.
And what can that tell you? How far back does that data go?
So when we drill the sea ice, we're not going very far back because most of the time we drill first year ice. So we get only basically the winter. If we drill north of Greenland, we may be still sea ice. I'm talking sea ice. There we get maybe 10 years max. And if we drill like a glacier, there we get many more years, 100,000 years, depending on where you drill.
So we've had an episode on the Antarctic already where we interviewed Neroli Abram, and she talked a lot about drilling ice in Antarctica to do paleoclimate studies and how far they can go back. What then, if you're only drilling like really young ice that's like 1 to 10 years old, what's the point of doing it? What are you getting out of it? What does it tell us?
So we're not doing it for monitoring of the Arctic usually. Although what there is now more and more, because we go every year with different ships, usually we always take a archive core that we store. So then you kind of build a bank of ice cores that could be used in the future. But when we take ice cores, mainly we do it for better understanding the system. Because the reason is that we don't know so much yet. We know more and more about the Arctic. But compared to the other ocean where we could go easily-ish with a boat, the studies of the Arctic, they started maybe 30, 40 years ago to be really complete. So it's way later. So we have way less here of understanding. The other big constraint we have when looking at the ocean is that we have sea ice. So we don't get access to the ocean via satellite images. Forget about all the images of the ocean. So to get the chlorophyll, for example, that we can get from satellite, we don't get that in the Arctic Ocean. So there are lots of obstacles by being in a frozen world in a way. But the ice cores we take in the Arctic, most of the time they have different purpose. It's not for paleoclimate. It's for understanding the system, understanding the pressure we can get, understanding the sea ice algae, the biology that is living in the ice, for also gas exchanges, trying to see the exchanges between the atmosphere and the ocean when we have the ice in the middle. So things like that.
So can we talk about the impacts and consequences of sea ice reduction and loss?
Yeah, so we've been through a bit of already the impact and consequences with the albedo effect, that we're going to get less and less sea ice and warming of the ocean. That's, so again, I'm going to focus on an ocean point of view. But when we remove the sea ice, suddenly we remove the barrier between the atmosphere and the ocean. That means we get the wind that will act directly on the ocean and possibly mix the ocean much more. The Arctic is a region where we have the quieter ocean. Like, honestly, it's almost, I would say, a bit boring to study when you want to look at turbulence and mixing, because there's really not much happening. But now with the sea ice removing, you would expect much more. The sea ice reduction also means more and more melt of the sea ice, which means more and more fresh water. Fresh water, once injected, and that is something that is being exported in the rest of the ocean. So that has impact in the rest of the ocean. One of them is that you increase what we call the stratification. So you put kind of a cap on top of your ocean by having this layer of fresh water on top. And that makes a lot of things happening more difficult, because then when you want to have mixing, so basically mix the ocean, if you have a layer that is thick on top, it's going to be harder to mix what's deeper. Does that make sense? Yeah. And that has consequences when we talk about deep convection of the Arctic, of the water mass, and that can bring into the thermoaligned circulation. So the long-term circulation of the ocean that impact the ocean globally. More locally, if we lose the sea ice, of course, we're going to impact all the ecosystems that are used to have sea ice on top. Suddenly, they don't have it. So, of course, we have the organism growing in the sea ice first that will be impacted. But even the one living in the ocean, suddenly they get a better access to light. The light, for example, if we don't have the sea ice. Sea ice blocks the light, especially sea ice with snow on top blocks the light. So there are a lot of consequences there.
What about you've touched on some of the global consequences there, Zoe, in terms of circulation changes, but what about something as simple as, or not simple, but sea level rise? Is that something that Arctic sea ice melt will contribute to in a similar way to Antarctic ice melt, or is it not on the same scale?
So actually, no, not at all the same scale. The reason being that the sea ice, as it's being said in the word, it's sea ice. It's frozen ocean. So it's water that was already in the system. So by melting it, you don't increase the sea level, or just a little bit by density differences, but like nothing significant. What matters when we talk about sea level rise is ice being stored on land. So the melt of Antarctica, for example, melt of Greenland, melt of glaciers. That's what matters. So sea ice for sea level, no, but Greenland with its glaciers, yes.
Mm.
That's the answer.
And how are Greenland's glaciers going?
They are melting. No, they are melting, like I would say the one in Antarctica too. Glaciers are not doing very well with global warming in general. So I don't know any place in the world where glaciers are actually thriving. Because even in Antarctica, at some point, there was this discussion that I can't remember, east or west was doing better than the other side. But I think this is kind of over anyway.
As an oceanographer specializing in sea ice, this may be slightly outside your area, but I think it is justifiable as it's Arctic or subarctic. But what about permafrost melting? Is that something that comes across your desk very often, or that you hear about from your colleagues? What's the go there?
Permafrost coming across her desk, like
literally just someone. Maybe that's what person knocking on the door was, just coming in and throwing some permafrost on the desk. Look, we lost some more.
Got that methane today.
So permafrost itself, no, that's not something I'm working on, and that's not something that I take into account in my studies. But what comes into account in a way in terms of land is that we get an increase of the river runoff from Siberia right now with increased precipitation. And that brings a lot of sediments, and that also increases the freshwater input first, but also brings a lot of sediments that tend to change the properties of the ocean in certain regions, in the Arctic especially. So permafrost, no, but yeah, rivers, yes.
Zoe, we're 21st century weather, so we're not just climate, we are also weather. I think we probably found ourselves doing a lot of climate in this series and not as much weather as some weather people may like, but we'll take that up with them some other time. Can you tell us anything about the potential relationship between these changes in the Arctic and the weather patterns that you see in the region? Is that something that people at your university are looking into? What's the go there?
Yeah, so I'm not an expert, so I don't want to say something that is wrong, but there are definitely changes in the Arctic. If you remove I know that if you remove the sea ice, for sure it will impact the boundary layer. So all the exchanges that you get between the atmosphere and the ocean also. I'm pretty sure it will have impact on clouds and fogs. And you see it actually when you're in the Arctic. As soon as you have open water, you get fog because you get moisture in the atmosphere. But if you get pure frozen ice, you have clear days. You see it. So when you go on the field, going in April is pretty nice usually because it's still purely frozen. It's cold, but it's gonna be good weather. If you go in the summer, you have more open water because the sea ice is melting. You have also the melt ponds that creates on top of the ice. So it's like when the ice melts and starts melting, or there is less and less sea ice, of course it breaks. So you get more, basically what we call flows. So pieces of ice that are moving around each other. Okay, so but in between them, we get open water. On top of that, on the floe itself, we get melting ice and snow that forms like swimming pools, small pools. So this also is water. And all that tends to bring a lot of moisture in the atmosphere and create fog. The classic example is that, for example, for flying helicopters for research, we need to see the horizon, more or less. On over 2 months cruise, usually it happens 10 days max. The rest of the time it's fog. So this has quite some consequences. The other thing I see more the atmosphere as impacting the ocean. So I don't know the other way around so much. But we see an increase and there's been showing that the polar vortex is getting a bit weaker and a bit more discontinuous. And at the same time, all the storms coming from the Atlantic are hitting more and more the Arctic because this polar vortex is not as strong as before. And that means we get an increase of the intensity of the storms, especially in the Arctic.
So is that how it's influencing the jet stream then? And then converse, like on that kind of train of thought, is that then affecting weather systems that may control other types of extreme events? So, blocking highs or something like that because of how the change in Arctic sea ice is affecting that jet stream and the systems that it brings.
Yes. I mean, I think the thing to get is that everything is connected on Earth. So by the butterfly effect, basically. So by removing sea ice, you will get an influence everywhere on Earth.
Yeah.
More or less strong, but you will get an impact everywhere. Same, we have this great event that is maybe more known now because it's happening a lot, this ENSO El Nino phenomenon in Pacific. And we see that the fact that it's getting warmer or colder in the tropical Pacific, this has an impact that has been documented in the Barents Sea, that's north of Tromsø.
Yeah, right. Okay.
So everything is connected through all this stream and all these cells that we have in the atmosphere.
Yeah.
It's funny, that's the second time that's come up this week for me, Zoe, because I was watching a talk given by one of our partners from the Met Office in the UK, and he was citing the example of wind speeds in the North Sea, where Britain has a lot of its offshore wind power generation. And he was saying that when you're in El Nino, then it affects wind speeds in the North Atlantic round into the North Sea. And it's crazy because I see those wind farms off the coast of Scotland when I'm there, but I wouldn't have imagined that what's happening in the sea over here would be influencing that side of the world. So it really is remarkable to think.
Even for me, I feel like it's, without fully understanding what's going on, like initially to think about it's a bit of a stretch. Obviously it's not, like, because these things have been measured and quantified. But it is, hard to think, something that's happening in the Pacific is affecting something, so far away from where it's actually occurring. It's called a teleconnection. But it's a very long one at that.
Yeah. And there are some with the sea ice that has been shown impacting, for sure, the Pacific. I can't cite them like now, but there has been some being shown also. but it's, yeah, the system is fully connected basically. So changing something in one place will for sure impact another one, but it's still a matter of finding where.
So as I've mentioned a couple of times already, we had Neroli come in and talk to us about what's happening in the Antarctic. And she told us these really sad stories about what's happening to the emperor penguin colonies and the basically failure of breeding that's happening there. Are the polar bears in the Arctic suffering from a similar fate? Are they at real existential risk because of how the Arctic is changing, or is it hopefully a bit of a better news story?
So the polar bears, so right now it depends where you are also and where you are, but the population at least around Svalbard are pretty stable, for example, so they're not decreasing sharply. What is for sure is that it's getting harder for them to get food because they go on ice during the winter, during the spring, sorry, for fishing. But if the ice is further away from land, because they go on land to get their babies and then they go away, they will use for sure much more energy to get to the sea ice and fish from there. What we see now, or hunt, they don't fish there. Well, whatever. I don't know how we call it. But what is sure is that there's been observed recently in Svalbard a change of behavior of polar bears that are actually getting more into town for food. And they are also starting to hunt reindeers.
They're starting to
Which
hunt
is,
reindeers. Oh,
yes,
poor Rudolph.
to get food there. So we see a bit, because the food that they usually eat at sea is getting harder to get, they turn around other opportunities basically to get their food.
They'll be okay as long as there's a steady supply of researchers in Svalbard to eat.
Yeah.
But it creates a problem because in Svalbard, at least they used to cohabit pretty okay. But now that the bear is becoming more closer, let's say, closer to the population, it's getting a problem. But it's a lot of discussion right now happening about that because the community Longyearbyen is on polar bear territory too at the same time. So it's quite hard. Like I'm not saying who has the right, but in a way it comes down to that. Yeah.
Do you know anything about the impacts of this changing Arctic for the indigenous populations in the region?
So I live in Norway. We don't really. It depends what you call the Arctic again. But,
I'm thinking, Sami people in Finland and Sweden, Siberia, Inuit people in Alaska and Canada.
Yeah, I know. So here we didn't have the sea ice all the way. So there is for sure changes, but I would say it's also a lot due to globalization and access to technology or whatever. What is as changing quite significantly is in Greenland. Because the Inuit population, they used to have their fjords fully frozen and with safe ice to walk on. And now the sea ice, I'm talking sea ice. Now the sea ice is coming later in the season, is breaking earlier in the season. And that means they can't anymore walk on it. So they don't have access to their fishing spot, for example, as easily as before. So for them, it has a huge implication. It also means you don't have, because some roads, like to go to the next village, for example, they were using this kind of frozen sea ice, but now you can't use them anymore. So you lose this kind of roads. So it has implication for them. And if you see any documentary about Greenland, about Inuits, so people talking, especially elderlies, they will all say that they see a change on a human life time.
Yeah, wow.
That's really sad. Really sad.
Changing tack slightly, I would like to ask more about your career, please, Zoe. So you mentioned that you've been in Norway for 6 years and Tromsø for 4. But what first drew you to polar science? How did your career lead you to where you are now?
That's interesting. I've been, yes. So I'm from the west coast of France. I've been sailing since I'm a kid. So spending my holidays on sailboats. That's what we were doing when I was a kid. And actually, I've always wanted to do research. It's a bit funny. I don't know why. Some kids wants to be a vet. I wanted to be a researcher, but more like volcanoes or biology. Of course, that's what you study at school. And I didn't know you could study the ocean. I learned that pretty late. And then I wanted to do like oceanography. The polar part came, I think, more naturally in a way. It's attraction. I remember when I was in primary school, we had a correspondent where we were writing letters in English to try to practice.
Pen pal.
I didn't want someone from the UK. I wanted someone from Canada. So I think it already started this like attraction to the poles. Like I went on holidays to Iceland and a lot of like cold places. So it's a bit. I think it's just a personal
Some sort
for
of
that.
magnetism at work, maybe?
Yeah, in a way. If you look at my scratch map, I have a scratch map. There's nothing in the tropics. It's a bit hilarious.
Yeah, right.
But the poles are done.
So Zoe, what are some of the biggest challenges that you've encountered in your career and to get where you are today?
I feel honestly, I think I've been relatively lucky in a way, but it comes down to work. I've worked a lot, I think, to get where I am, and a bit of luck. You need to be on the right projects to get the right path. I did my PhD in France, but already in collaboration with Norway. And then I got the path to get my postdoc there, and now my researcher position here. So I think that's a bit of luck there. I mean, luck and work at the same time, but you need to get the star aligned at some point, I think. That's how it goes.
I think that's the same for a lot of researchers, is that mixture of luck and working hard. Sometimes it just doesn't work out, and that sucks. But there's definitely a bit of luck there.
Yeah, so that's why. In terms of challenges, I would say, and I think a lot of, especially women doing fieldwork, would say the same, that it's actually being a woman on the field can be a challenge. And I felt it actually in one expedition like 10 years ago when I was just a PhD student. And more recently, still 5 years ago when I was at the Russian ice camp at the North Pole, Borneo, where you can feel that harassment is one thing, and that's something I've experienced, but also that you've been undermined because you're a woman and your opinion doesn't count the same. And that's, I think, more annoying for me, that you could feel that. Okay.
Would you say that that's more amplified in that sort of environment? Because certainly as a woman in science, I've experienced similar, but in that sort of environment where you are, with these people effectively for 1 to 2 months, that it's A, much more noticeable, but B, it just happens much more regularly and it's much more heightened as well.
Yeah, I don't know if it happens much more regularly. It depends. For example, on the Norwegian icebreaker, I know there's no problem there. And if there is something, you can really bring it up and it's going to be taken seriously, which is what you need, basically. But sometime, I think in these remote places, you also don't have communication with the outside, so it's hard. Like, you can't get out.
Yeah,
because
right. Yeah.
That's the thing. It feels easier to, I don't know, say something if you know that you can just get out.
Yeah.
But now on the ship, if you say something after 2 weeks, because I don't know, you're being harassed or something goes bad, you have no idea if that would make things better or actually make things worse.
Yeah. Okay.
Because that can happen.
Is that issue around harassment on fieldwork, is it a thing that occurs between researchers and the crew manning the vessels, or is it within the research teams themselves?
So I've always experienced, with the Russian ice camp, I experienced it with the crew more, but I think it's also a cultural difference, to be honest.
Yep. Is it a problem that isn't being addressed effectively within Arctic and Antarctic research? You've said that you didn't have any problems on the Norwegian vessel, but what's the attitude like towards this issue across the field?
I think it is a problem in general, especially, boats are very masculine dominated field. And I think if you go on land expedition, it's the same. So yeah. But I feel, at least my experience with it is that now we are more and more aware about it, at least. And it's being more and more open that it's a problem and that it can happen. So I know now when we go on ships, we quite often there is a person of trust that is being designated that you can go to if you have any problem. After, it can also be this person you don't want to talk to her, but usually they choose on expeditions. Usually they choose one male and one female, so that both are represented. So I feel like at least there are things being put to try to avoid that. I would say it probably depends on the nations on if they want to do it also. I'm talking more like European side and actually Northern European, because I heard a lot of issues on that, for example, with Spanish boats, similar to what has been said. So it's a hard topic, and I just hope basically that I think the community is more and more aware of it, and it's getting better. Also, it's getting better to get women in leading position in the field. And I think that in a way we're slowly changing the behavior into like women can also do the job. But I've been in situation not that long ago, 3 years ago, where it was very obvious, for example, that there was men being privileged because they had to unhook a leash from a helicopter sling. It's not physical job. It's just unhooking a sling. All the guys were on the ice. All the women were on the ship. Very obvious situation. But actually at the meeting within the specific team, at the meeting, it's actually the guy that told the team leaders that you can't do that. There's definitely discrimination. So it's also to show that it's changing, and it's also changing. It's not only women that have to speak out now. I think everyone is much more aware about this kind of behavior that has to be avoided.
I think it really helps to have the men call it out as well, and
Yeah.
you know, especially in this situation, but just generally, because you know it's coming from both sides. Everyone needs to see it. So, like, kind of on this issue, what's the ratio in fieldwork of females to males currently?
It depends what you do in terms of research. If you do biology, definitely more women than men. If you do physics, definitely more men than women. So it depends a bit what you do, honestly. So I know the team here I'm working with is the team, so I'm physicist, but it's mainly biologists. We're basically only girls, and we go on the field basically almost only girls. And it's working very well. There's no problem.
Yep, funny that.
But I've also been sometimes on a boat where I'm the only girl with only guys.
Wow.
And that happens too.
That would make me feel really uncomfortable, I will admit, even if they're people I know really well.
It depends if you go for long, like 5 weeks would be long now. It was because when we go 5 weeks, it's also a big ship. So there will be other women, and it's multidisciplinary and a lot of mixed teams. Then I would say we're almost usually 50-50, not far from that, or maybe 30-70, because it's so many teams that you will have some representations of women, at least in marine science. I think if you go towards geology, it's probably, again, many more men than women.
So even with that, like even on a big ship and it's multidisciplinary, you know, say we're at 40-60 ratios, or hopefully 50-50, maybe 40-60, even with such a large proportion of women, there's still that bias and discrimination that happens.
It helps to be 50-50, I would say. But what doesn't help is who's at the leadership.
Right. Okay.
And if you still have a white old man at the leadership, just to be a bit cliche, but that's a reality.
Not a cliche when it's usually the case.
But I mean, that's what all the documentary shows. That's usually the one that have creating problems there. So then discrimination can still happen. But my experience, at least in the recent expeditions, is that it's been really much better, at least. And if there are problems, you can talk about it, and it's been talked out, and usually it can improve.
What does it involve getting prepared for these trips and learning how to be safe?
Yeah, we have to to go on expedition, not everyone can go. So we have to go through a medical test first, more or less advanced depending on the expeditions, depending on the nations, but we all have to do at least a basic check to get done. And then we have some other things to do. So what's mandatory all the time is a survival suit training. So you wear clothes that you work on the ice that are floating, but are not water, like it's not sealed. So the water goes in. The thing is that if you work in survival suits, we do that sometimes, but it's cold and it's bulky. So we do that only in risky situation, if we work close to the ice edge or on very thin ice. But if we work on a piece of ice of 1 meter, it's not gonna break. Like, there's no reason it breaks, true? So you wear this flotation suit, but not sealed suit, not survival suit. So they make you basically jump in the water and try to get out on your own way. I think the main reason you do that is, okay, you have to try to get out, but the main reason you jump is to make you realize that you don't want to end up in this situation.
Do you do that in a pool somewhere like Tromsø or Bergen that's been like made the correct temperature, or do you do that when you get there in the real sea ice or the real sea?
Oh, so you don't do that from the ship, but I've done it in Longyearbyen by -20.
-20 outside temperature or -20 water?
The water doesn't get to -20, otherwise it freezes.
Of course, it'd be frozen. Just testing you, I knew that.
Yeah. We failed you.
Yeah. So it's pretty cold, but it depends. That was a bit extreme because it was a long ice campaign. Sometimes it's way less. What we have to do though is shooting. I know I have a shooting training every year to be able to carry the rifle.
Sorry, that I can't imagine jumping into water with ice picks and just finding your own way out.
So, I mean, for your information, Zoe, Sarah is a kind of a personal computer princess who doesn't do any field work.
I don't.
Not even going outside in the sun or getting muddy. So jumping into the Arctic Sea and then learning to shoot a bear is not on your agenda.
No, it's actually not. Like, I can kind of understand the training to use a rifle, but I just don't really want to shoot anything either. I guess no one does, to be fair. But yeah, no. I'll stay on my tropical island holding my cocktail and studying the heat.
But that's something actually I tell people quite a bit, because everyone is like, oh, it's amazing. Or sometimes they're like, I don't like field work. And I always tell people like, and it's fine. Not everyone has to like field work. Not everyone has to go on field work. And we need researchers that are also very good being behind the computer and running things. And I think there's not one that is cooler than the other, or there's not one that does a better job than the other. I think we just complement. It's a very good complement. And there's no like shame, because a lot of people are like, oh, but I don't know if I like field work, and I don't know. And students, PhD students typically. And I always tell them like, it's okay to not like field work. You don't have to like it. You're allowed to not want to go on the field.
I feel really validated now. Thank you, Zoe. I'm going to remember this conversation forever, I think.
I don't believe a word of that. There's definitely one that's cooler than the other, everyone. It's the shooting and the swimming.
Go away.
I would like to ask, what's the worst thing that's ever gone wrong in your like work out there in the field? And I don't mean like your computer crashing in the office. I'm going to stake my colors to the mast here. I want to know what's the biggest technical or logistical challenge that's come up for you.
Now, I had, this day where everything goes wrong. I had one of them, but on the field, and that's not a good feeling. Borneo ice camp. So this is a Russian ice camp that used to be set up every April. And they were doing crazy stuff there, like running a marathon. So it's a tourist ice camp, basically. It's a
Okay.
platform. It's run, and then you come,
I
you
would do
pay for
that.
your...
I would go there to run a marathon.
Oh, you changed your tune.
You know what? I love running. I have never
You
run
have to
a
run with
marathon.
a rifle.
Totally.
Run from the bear.
As I'm running from the bear. Yeah. Anyway.
So they were doing marathon, they were doing lots of stuff. And we were doing to deploy some instruments. It's quite heavy. We're talking maybe a ton of gear, and that we deployed. So it's on a 800 meters wire in the ocean with an instrument that goes up and down to measure the ocean. And then a big platform on top, like a buoy, that measures as a lidar to measure the clouds, the aerosols, and a lot of other stuff on it. And it's quite heavy deployment, and we're talking about 8 hours deployment. And it was minus 20. We didn't have a skidoo, so we carried first about, I don't know, but easily 500 kilos of gear by hand.
Wow. Okay.
I mean, we slide them, right?
Yeah.
We did have a pulk, but still.
When you went a 500 kilo back.
Yeah.
Yeah.
And then we had to drill holes. So, and everything got delayed because we thought we had the skidoo, the holes making, so drilling the holes took longer. And then by the end, you're tired, it's minus 20. Then you reach more or less dinner time, but it's daylight all the time. So you keep working. And that's when you start making little mistakes or things. Oh, but do I need to secure the foot of the tripod? It never falls. I don't need that. Oh, but do I need to put like this rope, exactly this safety rope? It takes 10 minutes, but it's good enough. It's going to be fine, you know, because you're tired and you want things to go fast.
Yeah.
And then what happened is that we had a big 3-meter tripod to put the instrument in. So like a big steel tripod, super high, with the hole in the middle, and we were working with instruments in. And basically the tripod fell. And it actually almost fell on me.
Oh, goodness. Oh.
Luckily, my colleague put his arm, and then the foot of the tripod fell like, I don't know, 50 centimeters away from me.
Yeah.
But
oh my goodness.
Then you don't really realize what's happening. But first, no one is injured, which is good because you remember you're not even on a ship where there is a hospital and a doctor. You're at a Russian ice camp 3 hours away by plane from Longyearbyen. Not the place you want to get injured, to be honest.
No medical emergencies, you're not getting out.
Yeah. And then I remember we went inside actually. We secured quickly the mess and we went inside, get a drink, and then we were like, okay. We still had like the instrument half deployed with the things that had fallen. And luckily, so we sat for 1 hour and then we went outside again to try to fix the mess. And it worked, and we got a paper published out of this data. But that was a good lesson I learned, is that safety is not for nothing. Like,
don't get crushed by your tripod in the Arctic Circle.
And do everything step by step. That was, I think, the worst kind of fuck up in a way I got on the field. Yeah.
Oh, I'm glad that it was a small enough fuck up for you not to get injured, but big enough for you to value your safety. What do you then find most rewarding about your work? What's something exciting and fun that might happen and that draws you back to these field campaigns again and again?
For me, what I love a bit the adrenaline of having to think fast to solve problems. Because when you're on the field, you can't just do it the day after. Like, it's very expensive to be on the ship. So I like this kind of emulation of trying to think fast. There is a problem. Okay, how we fix it? That's a part that I really like. I feel my brain is going at 100%. The other thing I really love in expeditions is actually, I love the Arctic, like the ice and the lights. I think mainly it's the lights I love.
The northern lights.
Like, especially when you get this sunrise by the ice. And all this landscape and lights. I really love that. I've always said if I stop being happy, like there's always this excitement when you're on a ship the first time you see the sea ice. And it's always very exciting and you go and look and outside. I've always said if I stop having this excitement, it's time for me to not go anymore and leave other to go, like the younger ones or whatever.
Yeah.
But so far, I'm still very excited to see the ice.
Yeah.
When that moment happens, it'll be time for you to go to the tropics, unfortunately.
Yeah, come join me.
Yeah.
So like do you have any, like, is that wavering at all, or do you still feel the same amount of excitement seeing that sea ice as you did the first time you saw it from the boat?
I mean, of course, it's not the same anymore. And I see it when you have newbies that are on the ship and they're like, they will put an alarm at 3 a.m. to see the first ice. I'm not doing that anymore. I'll wait for breakfast.
It's still awe-inspiring. It's still amazing.
Yeah, it's not, but you still have these days that are still amazing. And I think I like in expeditions also is the contact with people. Because you're stuck in the same place with a lot of people at the same time. Of course, you have some you're never gonna get close to them, but otherwise you have lots of time to chat, especially before we didn't have the internet until 2 years ago. I mean, now we have Starlink on board, which is great and bad because now people are on their phone a bit more. But before, it's a place there's no phone. You grab a coffee with your colleagues. You actually chat with your colleagues. You're not looking at your phone. You go for lunch. There's no phones on the tables because there's no internet. The phone is useless. The phone is an alarm for the bedroom and maybe to take pictures. But that's basically the only use you have of a phone before.
We don't want an ice-free Arctic. We want a phone-free Arctic. I would have thought that you'd all just agree with each other that the internet isn't on, you know? Just like no one tell anyone. We're not reachable.
Oh, you do still put an automatic reply. I'm unreachable out of the office. You still do that.
At sea.
At sea.
Yeah.
Do not expect a response during this time.
Yeah.
We're down to the last two of my suggested questions, and I guess they're actually a little bit serious, so I don't even know if we want to ask them, but we will, and we'll see how they go. And I shall ask the penultimate question and leave Queen Sarah the glory of the final question.
Thanks.
So this is jumping back now to more science than personal, but I would like to know if there is any hope of reversing this trend towards Arctic sea ice loss and to a smaller extent of sea ice, or are we talking now purely about adaptation to this new reality?
Let's say for the next, I think, at least for the next 20 to 30 years, we have to adapt. That's not, I mean, it's not something, even if we were acting right now on the climate, we're not going to reverse the effects in a year. That's not happening. There is a lot of inertia in the system anyway. So sea ice right now, as it looks like, will disappear in summer, or at least has very high chance of disappearing in summer. But of course, so we need to adapt and we need to mitigate that. We need to work on adaptation plan there for sure. But at the same time, it's not a lost cause. Like, I think having actions maybe won't really, it will still impact how much decrease we will get and if there is a chance to recover after. And that's for sure. So it's not a lost cause to do actions there. That's how I see it.
Yeah, I think that's actually a really good message, that there's always hope, right? No matter how bad it gets, it's always hope that it could be better.
Sarah.
Oh, yeah. Hello. Yeah.
The glory is yours.
It is indeed. So I guess kind of continuing from this, how do you cope with this speed of change, of this environmental change that you're seeing with your work?
I try to not think too much about it because otherwise it's depressing, I have to say. So I focus more on my work, which is climate related, but I'm not running the models. I'm not someone running the climate models themselves. So I'm not on a daily basis working with the predictions. I see it more like a time of challenges than a time of desperation, on more a way of, okay, it's going to be new and let's try to see what's going to happen there. I see it more that way, but that's also a way for me to cope with it.
Yeah, sure. Yeah. It's in some ways, I guess, a bit of a protection mechanism. Yeah. Okay. That is a really depressing way to end the episode, Ian. Can we do better than that?
I got one more that I skipped over. I got one more. Let's try and liven it up.
Yep.
Is there one or more common misconceptions about the Arctic that you're often presented with by people? We may have presented many of them in this episode, but is there something that people often get wrong that you are gently correcting them on, or that people don't know about, that our audience would like to know about?
Oh, there are a lot. Usually it comes down to very basic things. So the sea level rise is one.
Yeah. That's hey. Yeah.
There's no island at the North Pole.
So there's no actual island where Santa lives? Is that what you're telling me? Oh,
no.
Damn it.
And it's actually just ocean and water. Like Antarctica is a continent surrounded by water. Arctic is an ocean surrounded by land. And that's actually quite a misconception. Oh yeah, another one. Polar bears and penguins don't know each other. Penguins are in the south, polar bears are in the north. So polar bears don't eat penguins.
Penguins are lucky that they don't know each other, I think.
Yes. We know who will come out on top, and it ain't the penguins.
Yeah. So yeah,
there you go. That's a bit more cheerful, isn't it?
Yeah, it's true, because the penguins are already dying. It's actually really sad.
Dude, come on.
That's it for today. Many thanks to Dr. Zoé Koenig from the University of Tromsø, the Arctic University of Norway, for coming on the show and enlightening us about this fascinating region of the world.
Next time, we're going to turn conventional thinking on its head and talk about our weather as a resource. Forget
coal, gas, or nuclear power. The weather is... Blah, blah, blah. The weather is... Let me do that line again.
I shall.
Thank you. Forget coal, gas, or nuclear power. The weather is the most powerful resource we have. Our lives in Australia and around the world run on weather.
To find out what we're talking about, join us for the next episode of Totally Cooked.
And we'll tackle the climate crisis together.
Yeah.